Okay, number 4. So when I did these notes, I originally intended for you guys to try this, and so I think it would be really cool if you attempted to do what I did in the previous problem by yourself, and then came back and watched the video to see if you got it right. So I'm just going to pretend like you're pausing right now to give it a shot. And here we go. Use the power rule to fill out the table below for f of x equals negative x squared minus 2x plus 8. Okay, so like before, I'm going to take the derivative. So if I take the derivative, that would give me minus 2x minus 2. And then I'll plug in some points again. Let's see. So negative 4 times negative 2 is positive 8, minus 2 is 6. So negative 3 times negative 2 is 6, minus 2 is 4. Okay, so I kind of got the pattern here. And I'll just check with negative 1. So negative 1 times negative 2 is 2, 2 minus 2 is 0. Okay, and then so the point of me having you take this table over here and put it over here is I was really trying to drive home the idea that if you take the point 2 on the original and then you plug it into the derivative, then the thing that you get out is the slope, and you can graph that over here. So 2, when I plugged in 2, I got negative 6. So negative 6 would be down here, and that tells me that the slope at 2 is negative 6, which shows up down there. So hopefully you got that idea. If not, let's try a couple more. So at negative 4, it's negative 6. Uh-oh, what did I do? Negative 4 is negative 6, and 2 is... Oh, it's because I can't read. It says at negative 4 that it's positive 6. Negative 4 is positive 6. And then at 6, it's negative 14. Okay, now I'll try to draw a nice line. And actually, I know at negative 1 it's 0, so that will help me make a straighter line. Okay, so then like before, we're going to ignore the equation that we have and just look at these pictures to see what we can work out just looking at pictures. And it's very similar to before. I have a maximum at negative 1, which coordinates with an x-intercept. The difference this time, though, is that a maximum beforehand, the slopes are positive, and after are negative. When looking at the derivative, that means that the derivative's y values are positive, they hit an x-intercept, and then they become negative. So now we can fill this out at the bottom. So f of x is increasing over the interval from negative infinity to negative 1. Because it has a positive slope on that interval. This means that the graph of the derivative is going to have positive y values. Over the interval from negative infinity to negative 1. And it's decreasing the rest of the time, so from negative 1 to infinity. And it has a negative slope there, which means that the slopes or the derivatives y values are negative. Over the interval from negative 1 to infinity. There's a maximum at negative 1 because the graph of the derivative has a, let's see, x-intercept. This is because a graph has a slope of 0 at a minimum or a maximum. Okay, so I did not talk about that earlier, but it actually makes a lot of sense, right? The maximum we know is going to have a slope of 0. You know, if I draw any kind of squiggly curve here, the maximums and minimums are going to have a slope of 0. So if you think about a slope of 0, how that translates to an x-intercept. Excuse me. All right, use the graph of the derivative to find the slope at x equals 9 of the original. Please do not use the equation. Okay, use the graph of the derivative to find the slope at x equals 9. Okay, so at x equals 9, it's probably like down here. So we'll say negative 20, and then we could check it. And actually that looks like exactly right. That seems to follow the pattern of the table. So negative 20. And then we should check, does this make sense for our original? And let's see. Yeah, that makes a lot of sense, right? At 9, this graph has got to be pretty negative. It's got to be pretty steep negative slope. So yeah, that seems to fit. Oops. Let's stop here and we'll go to the next one.